branch circuit for a welder should be sized based on the maximum amperage drawn by the welder. In the provided case, the welder has a maximum input current of 20 amps, so a 20 amp circuit would be sufficient. The power plug and cord should be sized according to the welder's maximum amperage draw. The welder in question has a 50 amp power plug and cord, which is larger than the maximum amperage draw. This is done to provide additional margin of safety and prevent overheating the cord and plug. Now let's look at some examples of welder specifications and branch circuit requirements. Firstly, consider a welder with an input amperage of 15 amps, a fuse rating of 30 amps, and a 30 amp power plug and cord. The branch circuit requirement here would be a 15 amp circuit. Secondly, examine a welder with an input amperage of 25 amps, a fuse rating of 50 amps, and a 50 amp power plug and cord. The branch circuit requirement would be a 25 amp circuit. Thirdly, take the case of a welder with an input amperage of 40 amps, a fuse rating of 80 amps, and a 60 amp power plug and cord. The branch circuit requirement would be a 40 amp circuit. To summarize, for a welder with an input amperage of 20 amps, a 20 amp branch circuit is sufficient. The power plug and cord should be rated for at least the maximum amperage draw of the welder, which in this case is 50 amps. It is always recommended to consult with an electrician or refer to the manufacturer's specifications for specific installation requirements. Now let's delve into the specifics of how these ratings are determined and why safety margins are important. When selecting a branch circuit for a welder, the primary consideration is the welder's rated input amperage. This is the maximum amount of current the welder is designed to draw under normal operating conditions. It's crucial to identify this value, which is typically found on the welder's nameplate or in its technical specifications. The National Electrical Code, or NEC, provides guidelines for sizing branch circuits based on the connected load. For welders, the NEC often requires the branch circuit to be rated at not less than 100% of the welder's primary current. This ensures that the circuit can handle the continuous load of the welder without overloading. It's important to note that some welders may have intermittent duty cycles where they are not constantly drawing their maximum amperage. In these cases, the NEC may allow for a reduction in the required branch circuit size. However, it's always best to err on the side of caution and consult with a qualified electrician to determine the appropriate size. Regarding the power plug and cord, these components must be rated to handle the maximum current that the welder can draw. In the given example, the welder has a 50 amp power plug and cord, even though its input amperage is only 20 amps. This is a common practice to provide an additional margin of safety. The larger plug and cord have a higher current carrying capacity, which reduces the risk of overheating and potential fire hazards. The NEC also specifies requirements for the type and size of conductors used in power cords and plugs. These requirements are based on the ampacity of the conductor, which is its ability to safely carry current without exceeding its temperature rating. When selecting a power plug and cord, it's essential to choose components that are rated for the appropriate voltage and amperage, and that are listed by a recognized testing laboratory, such as Underwriters Laboratories, or all. Now let's examine why the fuse rating is higher than the input amperage. The fuse, or circuit breaker, is a safety device designed to protect the electrical circuit from overcurrent conditions. It is intended to trip and interrupt the circuit if the current exceeds a predetermined level. The fuse rating is typically higher than the welder's input amperage to allow for short-term current surges that may occur during welding operations, such as when striking an arc. However, the fuse rating should not be excessively high, as this could defeat the purpose of the overcurrent protection. The NEC provides guidance on selecting the appropriate fuse or circuit breaker rating for welder circuits. Generally, the overcurrent protection device should be rated at not more than 200% of the welder's rated primary current. This ensures that the circuit is adequately protected from overcurrents while still allowing for normal welding operations. Let's consider some potential issues that can arise from improper circuit sizing. An undersized branch circuit can lead to several problems. Firstly, it can cause the circuit breaker to trip frequently, interrupting welding operations. Secondly, it can cause the conductors in the circuit to overheat, which can damage the insulation and potentially lead to a fire. Thirdly, it can reduce the voltage available to the welder, which can affect its performance and weld quality. On the other hand, an oversized branch circuit can also be problematic. While it may prevent nuisance tripping of the circuit breaker, it can also reduce the effectiveness of the overcurrent protection. In the event of a short circuit or ground fault, an oversized circuit breaker may not trip quickly enough to prevent damage to the equipment or wiring. Therefore, it's crucial to select the correct branch circuit size based on the welder's specifications and the requirements of the NEC. Now, let's discuss some additional safety considerations when installing and operating welders. Firstly, always ensure that the welder is properly grounded. Grounding provides a low resistance path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. Secondly, inspect the power cord and plug regularly for any signs of damage, such as cuts, cracks, or loose connections. Replace any damaged components immediately. Thirdly, keep the welding area clean and free from flammable materials. Welding can produce sparks and hot slag, which can ignite combustible materials. Fourthly, wear appropriate personal protective equipment, including a welding helmet, gloves, and protective clothing. Welding can expose you to intense light, heat, and fumes, which can be harmful to your health. Fifthly, never operate a welder in wet or damp conditions. Water can conduct electricity and increase the risk of electrical shock. Sixthly, ensure that the welding area is adequately ventilated. Welding fumes can contain harmful gases and particles, which can cause respiratory problems. Seventhly, follow the manufacturer's instructions for the safe operation of the welder. These instructions will provide specific guidance on how to use the welder safely and effectively. In conclusion, selecting the correct branch circuit size, power plug, and cord for a welder is essential for safety and performance. By following the guidelines provided in the NEC and consulting with a qualified electrician, the welder can be installed and operated safely and reliably. Always remember to prioritize safety and to take precautions to prevent electrical shock, fire hazards, and exposure to harmful fumes and radiation. The information provided here serves as a general guide, but it's important to consult the specific requirements of the NEC and the welder manufacturer's instructions for detailed information and guidance. Understanding the welder's input amperage is paramount. This value dictates the minimum size of the branch circuit required to safely power the equipment. Overlooking this aspect can lead to frequent circuit breaker trips, overheating of wires, and potential fire hazards. The NEC provides tables and guidelines to determine the appropriate conductor size based on the amperage and the insulation type. These tables take into account factors such as the ambient temperature and the number of conductors in a raceway. When selecting a conductor, it's important to choose one that is rated for the appropriate temperature. For example, conductors with the THHN insulation are rated for a higher temperature than conductors with the TW insulation. The power plug and cord act as the interface between the welder and the electrical system. It's crucial to choose components that are rated for the voltage and amperage of the welder, and that are listed by a recognized testing laboratory. The plug should fit snugly into the receptacle to ensure a good electrical connection. Loose connections can cause arcing, which can generate heat and potentially lead to a fire. The cord should be long enough to reach the receptacle without putting undue strain on the connections. Avoid using extension cords if possible, as they can reduce the voltage available to the welder and increase the risk of overheating. The fuse or circuit breaker acts as a safety net to protect the electrical system from overcurrent conditions. It's important to choose a fuse or circuit breaker with the correct amperage rating for the welder. The rating should be high enough to allow for normal welding operations, but low enough to trip and interrupt the circuit in the event of a short circuit or overload. The NEC provides guidance on selecting the appropriate fuse or circuit breaker rating for welder circuits. It's essential to follow these guidelines to ensure that the electrical system is adequately protected. Grounding the welder is a critical safety measure. Grounding provides a low resistance path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. The welder should be grounded to a properly grounded metal enclosure or to a grounding electrode system. The grounding conductor should be sized according to the requirements of the NEC. Regular inspection and maintenance of the welder's electrical components is essential for safety. Check the power cord and plug for any signs of damage, such as cuts, cracks, or loose connections. Inspect the wiring connections inside the welder to ensure that they are tight and secure. Clean the welder regularly to remove any dust or debris that could interfere with its operation. If you notice any problems with the welder, such as unusual noises, excessive vibration, or electrical shocks, disconnect the welder from the power source and have it inspected by a qualified technician. Following the manufacturer's instructions for the safe operation of the welder is crucial. The manufacturer's instructions will provide specific guidance on how to use the welder safely and effectively. Pay close attention to the safety warnings and precautions. If you have any questions about how to use the welder, contact the manufacturer or a qualified technician. Working with electricity can be dangerous. It's essential to take precautions to protect yourself from electrical shock. Always disconnect the welder from the power source before working on it. Wear appropriate personal protective equipment such as rubber gloves and safety glasses. Work in a dry area. Never touch electrical components with wet hands. If you are not comfortable working with electricity, hire a qualified electrician to do the job. By following these guidelines, welders can ensure that their electrical systems are safe and reliable. Regular attention to detail and adherence to the NEC will help to prevent accidents and ensure that welding operations can be performed safely and efficiently. Remember to consult the latest edition of the NEC for the most up-to-date information and requirements. Proper planning and execution of the electrical installation are key to a safe and productive welding environment.